In this video, we are starting section 3.4 on combining functions. So our goals are to discuss how we combine functions by adding them, subtracting them, multiplying them, dividing them, and then by something called composition. And that's going to be the main focus of this section. Composition has to do with when you plug one function inside of another. And then the second goal is we're going to set up some compositions of functions and show how we can simplify them and find their domain. Okay, so in this video, I'm going to focus on, what are the different ways to combine functions? So let's get right into an example. Let's let f of x be x squared and g of x be 3x plus 2, and I want to evaluate each expression. So in part A, we have this notation that says parentheses f plus g parentheses x. And what that notation means is, well, we want to add the two functions together. That is just notation that indicates adding functions together. So my first function is x squared. I'm going to be adding that to the second function, 3x plus 2. Okay, it didn't say I need to simplify it or factor it, so it's totally fine to leave it like this because it didn't specify that. Okay, all right, part B. What if I had a minus sign in this parentheses thing? Well, that's notation for subtracting functions. So I could write that as f of x minus g of x. So if I subtract my functions, I got x squared minus g of x. So when I subtract g of x, I got to subtract this whole thing. So I got to put a parentheses around it, minus 3x plus 2. And then that minus sign would distribute. So I get x squared minus 3x minus 2. All right, that's my subtraction. In part C, if you put f times g in a parentheses like this, that's a notation that means, well, we are multiplying the functions together. It's f of x times g of x. So f of x is x squared, and that's multiplying g of x, which is 3x plus 2. All right, that's my multiplication. I didn't need to do anything to it like distribute, because it didn't say simplify or whatever. So it's fine to leave it like this. In fact, in some ways, I would say this is more simplified because this is factored, and distributing the x squared would unsimplify it. Okay, part D, if I have f over g like this in a big old parentheses, that's a notation that means, well, we are dividing our two functions. So if we divide them, f of x is x squared divided by g of x, which is 3x plus 2. Cool, that's my division. Okay. And I want to end this video with two examples where we do something more interesting. So this circle notation is a notation that means we are composing functions. We are plugging one function inside of another function. So if I have f circle g of x written like this, that means f of g of x. In other words, we are plugging g of x in to the function f. So wherever the x is in the formula for f of x, I'm going to be plugging the g of x formula into that x. Okay, so my f of x says, well, I'm having something squared, but now I'm going to be plugging in g of x, this whole thing, into that x. So instead of x squared, it'll be 3x plus 2, that whole quantity getting squared. Okay, and that's that. Part F, what if I do it in the other order? What if I do g of f of x? So now I have g of f of x, g of f of x. Okay, so when I do g of f of x, well, what's the formula for f of x? F of x is x squared. So I'm going to be plugging x squared into my formula for g where the x is. Where that x is, I'm going to plug in the whole formula for f of x in there. Okay. So if I do that, instead of getting 3 times x plus 2, I'm replacing the x with x squared. That whole thing gets plugged in. So I get 3 times x squared plus 2. Maybe I could have written that down for the previous example as well. So let me go back, and because I sort of forgot that. F of g of x means, well, f of, and what was my formula for g of x? Well, it was 3x plus 2. 3x plus 2. And that's what indicated to me that, well, I got to take the whole thing in the parentheses, which is 3x plus 2, and I got to plug it into my formula for f of x where the x squared is. And that's why the whole 3x plus 2 got squared like I had it here.